I had a request to work out problems 3 and 4 on this test review sheet. And so let's walk through these. The instructions for both problems are to write an exponential function to model each situation. And then part 2 of the answer will be to find the value of each function after 5 years. So the first thing to realize is that when you're writing an exponential function, it always looks like this in general. Y equals a number A that we call the initial value times another number B that will either be a growth factor or a decay factor, depending on the problem being growth or decay, obviously. And then B will be raised to the x power, which represents an amount of time that has passed. So from this initial value, a certain amount of time has passed, and that value has either gone up or gone down. We either have growth or decay. So with that in mind, both of these problems will start like this. Let's take a look at number 3. We have this car that was purchased for $32,500, and we're told that it depreciates. So that's a fancy word in the business world that means it is decaying. It is losing value as it's being used, as it's being driven, as time passes. It's not worth $32,500 like it was when it was brand new. So it loses value. That's just another way of explaining the word depreciates. All right, so the initial value, the new car cost, is $32,500. That's what A represents. All right, so I'm going to start building this function, and I'm going to plug into these variables. A is the initial value, 32,500. And we said earlier that B, in this case, is going to be a decay factor. And the way you get B is, whether it's growth or decay, it really doesn't matter. You always start with the number 1. And just remember it this way. If you have decay, you're going to be subtracting something from that. If you have growth, which is what we're going to have, just to give you a little preview of number 4, you notice that the baseball card was purchased for this amount, but it's increasing in value over time. Well, that's exponential growth. To get B for a growth problem, we're going to start with 1, and then we're going to add a percentage. Okay, so what we subtract in number 3 is the 6% as a decimal. So just go to your calculator and do 1 minus 0.06, and that gives you your decay factor, which is 0.94. Okay, so the first sentence is answered right here. My function that models this situation, and I want you to show me, that in 2 different parts when you do your test. There's the function model for this particular car situation. Now we'll get specific and we'll find how much this car is actually worth after 5 years. So now you're going to go to your calculator, just use this formula, this function that you came up with, and in place of x, you're going to put an exponent of 5. So you're going to raise this to the 5th power. All right, so we go to our calculator and we key in 32.5, parentheses 0.94, close parentheses, and I'm going to raise that 0.94 to the 5th power. And on these problems, you can round to the nearest dollar. It's okay. And you notice that the amount on your calculator rounded to the nearest dollar is 23,852. And that's my Y, which Y represents how much it is currently valued after depreciation. All right, so answer part 1 is the function. Answer part 2 is the value of the vehicle after 5 years. All right, so let's take a look at number 4. Same starting point. The initial value is going to be $50. That's how much we paid for the card. This time we're going to have a growth factor. So again, starts the same way. We start with 1, but since it's growth, we're going to be adding the decimal form of 3%, and that's 1.03. And that's going to be raised to the x power. X represents an amount of time that has passed, so that's answer part 1. I'll say answer part 1, that's the exponential function. And now we're going to use this to see how much this baseball card is worth after 5 years. So we just go to our calculator and we let the exponent for 1.03 be 5. And that'll give us our answer. So 50, parentheses, 1.03, close parentheses, raised to the 5th power. And to the nearest dollar, it says 57.9637. So to the nearest dollar, we would just say 58. And that's how those exponential function problems work, whether you'll have growth or decay. I'd be prepared for both. And hope that helps. And if you have any questions, let me know.